So this is the question number 4, which came in year 2020, and it is an engineering mathematics set 2. The question says the following differential partial equation is defined for u used to ux function. So dx by dy is equal to d square x by dy square, and the y is greater than 0, and x lies between x1 and x2. Okay. So the set of auxiliary conditions necessary to solve the equation uniquely is three initial conditions, first option. The second option is three boundary conditions. The third option is two initial and one boundary condition. And the last option is one initial and two boundary conditions. Okay. So basically, first understand what is secondary, what is the form of second order partial differential equation. So second order PD. Okay. So second order PD can be represented as A d square u by dx square plus b d square u by dx dy plus c d square u by d square plus function of x y du by dx comma du by dy is equal to 0. Okay, so this is called a second order partial differential equation. So this is equation 1, suppose. So now there are three conditions. Equation 1 is parabolic. Okay, if b square minus 4ac is equal to 0. Okay, so this is one dimensional heat equation. One dimensional heat equation. Okay, so b square minus 4ac. So you can write it as d square u by dt. So because y is greater than equal to 0, so we are replacing y with t. Okay, d square u by heat equation with temperature. So basically, to add meaning is equals to c square d square u by dx square. Okay, so d square u by dt is equal to d square u by c square d square u by dt square. So one dimensional heat equation for parabolic PD, two boundary condition and one. So two boundary condition, because to solve this differential equation you have to integrate it two. So two boundary condition, and okay, so it will be du by dt. Sorry, this won't be square. Du by dt is equal to c square du by square u by dx square. Okay. Now for two boundary conditions and one initial condition is required for the solution. One initial condition, because number of initial condition depends upon the higher order derivative of partial differential with respect to time. So du by dt has a higher derivative of 1. So one initial condition is required, and since we have to derive it two times to solve this problem, it is needed to be integrated two times. So therefore, we need two that will give two arbitrary constants. So therefore, two boundary conditions is required. Okay. So the first thing is basically number of so number of initial conditions is equals to highest order of time derivative in partial differentiation. Partial differential. So in this higher order time derivative, du by dt is 1, so it is 1. So number of initial condition is 1. Now the number of boundary conditions, so as I mentioned, du by dt is equals to d square u by dt square c square. To solve this, you have to integrate it two times. So that will introduce two arbitrary constant. So for two arbitrary constant, you need two boundary conditions basically. So therefore, two boundary conditions. Okay. So this is one type based on the question. The answer will be so one initial condition and the two boundary condition. Now, so this case is specifically for the parabolic. So now there are other cases which is also possible. So equation one is parabolic. Now continuing this, so if we continue this, so equation one which I mentioned there. So equation one is elliptic. So other question can come in this way also. Election elliptic if b square minus 4ac is less than b equal to 0. This is Laplace equation in 2D. Okay. So here d square u by d square y plus d square u plus dx square is equal to 0. For solving this elliptic, you need four boundary condition, and so four boundary conditions are only required for this. Okay, four boundary conditions required for solution. Okay, now third thing is equation one is hyperbolic if b square minus 4ac is greater than 0. So b square minus 4ac is greater than 0. So we will get d square u by dt square c square d square u by dx square. So this is wave equation 1D. Okay. So for 1D, so this is a hyperbolic. For this, we require two boundary condition and two initial condition for required for getting the solution. Okay. So I have explained everything. So in this question, option D is correct.